Hi, my name is Conrardy, and this is my video application for EECS 281 Programming in Data Structures. I hope you enjoy. In today's lesson, we will be going over the linked list. We will start by talking about what linked lists are. Then we will talk about their disadvantages and their advantages. Finally, we will go over a basic implementation of a for linked list and some of its member functions, to give you a better understanding of how a linked list works. So what are linked lists? Linked lists are sequential containers of data elements, or datum. This means that they maintain the order of elements, whether sorted or unsorted. Each element in a linked list also contains a link to a successor, and sometimes predecessor. The successor link can be seen in the animation below for linked list. There is a pointer in each element which points to the next element within the linked list. The predecessor pointer can be seen in the doubly linked list animation below. While there is a forward pointer which points to the next element in the linked list, there is also a previous pointer which points to the previous element in that linked list. There are several disadvantages to linked lists. Unlike arrays and vectors, elements are not indexed, meaning you must start at the beginning in linear search to find the kth element in the linked list. This can be seen in the for linked list animation below. Linked lists also have several advantages. Unlike arrays and vectors, there is no need to copy all the elements once it reaches its max size. Insertion and deletion can be quick. As seen in the insertion function below, a new element is created, to which the first pointer now points. This element points to the previous first pointer. For deletion, a victim pointer is made. This victim pointer points to the previous first element. The first pointer points to the second element in the linked list, and the victim pointer is deleted. We will now go over the for list implementation. We will talk about the node structure and the functions empty, front, push front, and pop front. Although we will not talk about them today, it is important to remember that the for list contains the big three: a destructor, a copy constructor, and an overloaded assignment operator. Nodes contain datum, which hold values of different type, and a pointer to a successor and sometimes predecessor. For a for linked list, a datum and a next pointer is contained within a node. For a doubly linked list, a datum, a previous pointer, and a next pointer is contained within its node. The empty function returns true if the first pointer is pointing to a null pointer. It returns false else. For the front function to operate correctly, you must confirm that the first pointer does not point to a null pointer. If this is true, we can return the datum that the first pointer points to. For the push front function, we will create a new node pointer, which receives a datum and points to the previous first node. This can be seen twice in the animation below. For the pop front function, we must first confirm that the linked list is not empty by making sure that the first pointer does not point to a null. If this is true, we can continue with the rest of the function. A new node pointer, victim, is created, which points to the previous first element in the linked list. The first pointer is now moved to the second element in the linked list. The victim pointer is then deleted. For list traversal, we will use the print list function. Given a node pointer traverse, which points to A, we will print out A as long as it's not a null pointer. We will then find traverse next, which points to B. We will print out B given the same logic as A. We will continue this method until we run into a null pointer. We have now run into a null pointer and the function ends. Thank you for listening. I hope you enjoyed the sample lesson of EECS 280 programming and intermediate data structures. If you wish to contact me, you can use the following information to get in touch.